Thank you all for being here. This is very exciting. So, my name is Jonathan Anderson, and I do HPC product at CIQ, which primarily means Warewulf and Fuzzball, and a little bit of Aptainer, which we have kind of bundled into, from a product standpoint, the Warewulf offering these days. But I'm going to talk about Warewulf, which you maybe already know and are familiar with from the Warewulf community. And Warewulf Pro, which is our commercially supported offering of Warewulf. We can support Warewulf just that you pulled off the community as well, but we have kind of a bundled offering called Warewulf Pro that we'll talk a little bit about and what's included in that. And the thing that everyone wants to know about, how to use Warewulf to provision to your disk, which is a brand new feature in 4.6.4, which is the current release. And we're going to be incrementally adding on features to that to make it more like what people are actually asking for all the time. When can it be stateful? But we'll make a little bit light of that as we go. And then at the end of the presentation, so this is scheduled for like 15 minutes, but we have time afterwards where we can have a little mini BOF or TSC meeting or Warewulf user group meeting, as people would like to hang out if they're interested and have questions. There will be a slide of features that I'll kind of breeze through at some point, and then at the end I'll pull that back up if people have questions about new features that are in Warewulf or anything that you're doing with it that you would like to talk about. But if you're not familiar with Warewulf, Warewulf is a stateless cluster provisioning system that's primarily targeted at our HPC use case, but it's definitely viable outside of that. We have seen people use it for, the biggest second thing that people ask about is, can I provision Kubernetes with it? We don't have a stack like that today, but you can totally do it, and we will be incorporating it into our stack in the not too distant future. But a thing we have done with it is deploy storage clusters with it, and we're actually really excited for that. We explicitly provisioned some BGFS clusters with it, and that might sound counterintuitive to use a stateless provisioning system to provision a storage system, but it ended up being a really great experience for us and for the customer, so we're hopeful to do more of that. At its heart, Warewulf is a server process that sits on your network on a virtual machine or on a server somewhere and configures a handful of additional services like DHCP and TFTP to allow compute nodes, I'm getting a little bit of feedback here, to allow compute nodes to boot an operating system over the network. And every time a compute node boots, it fetches a fresh copy of its image and some configuration overlays, and we'll talk about those in a minute, from the server and boots from system memory. And so that's what we mean by stateless provisioning. You're loading your image into memory. If the node goes away and comes back, it gets exactly the same thing it got the last time it turned on. A really good side effect of this that we like to talk about is, if there's a problem, you know that the problem is your hardware because it's the same image that worked before. Obviously things can go wrong with your image, but if your image was working before and it's not working now, it's something has changed on the node, not in your image, right? So there are 4 primary things that you need to know about when you're in a Warewulf cluster. We've actually simplified this from before, so it makes it easier to talk about. There's the nodes that are in your cluster. This is not that confusing, but inside of Warewulf, there's a set of metadata that we know about your node, things like what network interfaces it has, what its host name is, things like that. Profiles are inside of Warewulf an abstract node. It has all the same properties that a node has, but then nodes can inherit from one or more profiles. So you can say things like, have a compute node, or have an image, and configure it with this, and have some overlays, some configuration, and maybe this network, and then you can mix and match those profiles onto a node. So you can say, this is the profile that configures a node to be on this network. This is the profile that configures the node to boot this operating system, and then mix those into your node, and that's a way to group nodes and not have to have redundant configuration from each node over and over again. Images are the operating system image that you're provisioning. And we've had a slight naming change here. In earlier versions of Warewulf 4, we called this containers. That was kind of some marketing jargon that we were using to emphasize the idea that you can build, and in fact we recommend that you build your node images using a container tool, like Podman, like Docker, like Aptainer, like Singularity. You can use those tools to build your node image, and they look a little bit different than what you might be expecting in a microservices architecture, because our containers have an init in it, and have a kernel in it, and have everything that you need to boot an operating system, but you can use all those same tools. You get the benefits of an OCI container registry for layering. When you're rebuilding images, you don't have to rebuild it from scratch every time. But you can then import that image into Warewulf and boot it on bare metal. There's no actual container runtime when you're actually booting your node. And then our fourth thing to know about are overlays. So the image is large, can be, from as small as several hundred megabytes to as large as several dozen gigabytes, which is not a great situation, but some people find their way there. You don't want to have a copy of that image for every single node, because then it gets even bigger. So the overlays are either static configuration files that you want added to your node, or templated configuration files, and those templates are executed for each node individually. So if there are things that configure that node different than other nodes in your cluster, that is expressed as a template, and then when you build that overlay, it gets mixed into your image when the node boots. And so the final state that the node has is a combination of the operating system image and the overlays that are configured for it. So Warewulf Pro is everything that you hopefully like about the open source and community supported Warewulf server, but then we add some things to it. So we have helpfully organized it in a grid of 4 things again. So the first is a web interface. We had a lot of people that were interested in Warewulf, but then when they would take it up at a business level, or especially at an integrator, they would say, but does it have a web interface? And we would say, no, and now it does. So I'll talk more about that, but yeah, I won't go into it here. I have other slides for it. We distribute, one thing that Warewulf Pro is a catalog of pre-built images and pre-built overlays for those images. So instead of having to build the image that you want to boot yourself and build up your software stack on it, and then writing all your own overlays and configuration files for it and doing all of that work yourself, you can totally do that. Or you can pull those from our Warewulf Pro catalog, and you can have a Slurm cluster by just importing an image, adding that overlay to it, and saying where your Slurm server is, and you didn't have to actually make any configuration changes. So that's kind of the vision we have for the kind of turnkey experience we're looking for with Warewulf Pro. It's still relatively early days there, but that also means that we're very eager to impress. And if there's something that you want to see in the Warewulf Pro images, either a complete stack that you want to be able to do that you don't want to have to build yourself, we'll work on that with you, make sure it meets your requirements, and then package it together in the catalog and maintain it for you. And then the fourth thing, of course, Warewulf Pro is a fully supported offering from CIQ. So you get support not just for Warewulf, but we also bundle in support for Apptainer, which is the kind of premier community HPC container runtime. You may know it as Singularity before. The idea here was if we're going to be delivering full stack HPC experiences, that should support containerization. So we want to have Apptainer in those images, and we're not going to do that if we're not supporting it. So if you have a Warewulf Pro cluster, you will have Apptainer on that cluster, and you will have support for that Apptainer environment. And then we also have training that we can either do on-prem or remotely if you would like to engage with us for that training as well. So the web interface is based on Cockpit. You may or may not have experienced this before, but Cockpit is a systems-focused and systems-facing web interface that if you're using Rocky Linux or any enterprise Linux variant, you already have access to this. You might not have it installed, but it's pluggable. And so we built a plugin for it that does Warewulf Pro. And so we'll use that in the demo that we're going to do here in a moment, but you just grow a Warewulf Pro tab here on the side, and then it talks to your Warewulf server, and you can see your nodes, profiles, images, and overlays, and edit them, configure them, do all kinds of things there. I was pleased when this thing got to the point where I found myself using the web interface instead of the command line to do simple things, and I realized that perhaps it was in fact useful. The turnkey images that we provide, as I said, they come with Apptainer. The majority of these stacks that we're building today are based on the OpenHPC stack. We do a lot of work with OpenHPC. Warewulf 4 is one of the primary provisioning systems that are enabled by OpenHPC, and we did a lot of work with them to make sure that OpenHPC 4 had what it needed, especially for Enterprise Linux 10 support, to continue working with Warewulf 4. So we actually have representation here in the audience today from OpenHPC. Timothy Middlecloop is a member of both the OpenHPC community and the Warewulf Technical Steering Committee, and we're glad to have him there. But then we build, I guess I didn't put graphics for it, but we build Slurm and PBS stacks out of OpenHPC and provide those images for you today. And then we also have a pre-built turnkey stack for our Fuzzball offering as well. If you're a Fuzzball customer, you can deploy one of those with this and just be ready to go from day one. Oh, sorry, and I didn't talk about the overlays. So the overlays then give you the experience of not having to write the config file. You just import the Slurm overlay into your node, and it looks for a tag. So you tag your node with where your Slurm server is, and it just configures it to fetch the config and do all of that for you. Same thing with PBS. And there are others too. We have like a cronny overlay that you tell it where your time server is, and it configures all that for you. And then we basically talked about support and training already. I'll skip that. We have a little bit of an eye chart here for new features that went through the change logs of everything in Warewulf 4.6. I'm not going to go down each one here, but if there's something here that interests you, bring it up in a question at the end, and we'll come back to this slide. I'll have this up anyway. And these are relatively new things in Warewulf that we are excited about, but sometimes is difficult to get information to people out. Maybe one thing that I will talk about is Warewulf 4.6 included a complete rewrite and reorganization of our documentation. So if you've had trouble learning something about how Warewulf works before, I encourage you to go to warewulf.org and check out the new documentation. It's really good, and we also have been very opinionated since 4.6.0 about having a complete change log with each release. So all of this information was just drawn from me kind of going through each, not just the change log, we've had that forever, but the release notes, that's what I'm trying to say. We have complete release notes for each release, and it gives much more detail about each of these things, but of course we can discuss it here at the end. Two things that are coming up that we don't have in Warewulf today, but are expected in the very near term 4.6.5 that we were hoping to have ready for the show, but is not ready today. One thing that is merged already is multi-architecture Warewulf client. So there's a little binary that sits on your compute node optionally. It doesn't have to be there, but that helps you manage the configuration of the node over time once it's already booted. And this thing is a binary, so it was compiled for the architecture of your server. There was nothing else standing in the way of managing systems of different architectures from a single server. And of course, with like a Grace Hopper environment, what people want to do is they want to have an x86 server, and then they want to have x86 and ARM clients. The only thing that made that in any way uncomfortable was this tiny little binary that was only for the architecture of the server. Now, in 4.6.5, we will be distributing one that is like that, an overlay that is whatever architecture your server is, but also an overlay that is explicitly x86 and an overlay that is explicitly ARM. And that ended up being embarrassingly trivial, and I wish we had done it a year ago. But we would just direct people to do this themselves. Now you don't have to. You just import the overlay that you want. And then the second thing is we're adding a help feature to the command line. So now, we have these overlays. They respond to all manner of metadata about your node, including tags that you might define yourself or that we might have assumed you might set on your node, things like what your time server is. But it's been kind of difficult to know what variables a given overlay will respond to. You kind of have to go read the template, or maybe we documented it. This is doing some introspection on the templates, so you can run a help command. It's tiny here, but this little, maybe it looks better on the screen over here than it does on my screen. This is like the early help output of the variables that a given overlay will look at and what it's going to use them for. So there's some syntax for embedding that documentation in the overlay, and that should make these overlays easier to discover and understand over time. We're really excited about getting that into the next release, and this is the thing that's blocking the release because we want to get it out there. So let's talk about stateless provisioning. So we said stateless provisioning means that you boot your node up, and every time you do, you get an image. But that doesn't mean that your node has to be diskless or that the node itself has to be stateless. So ever since version 4.5.0, which came out last year, like early last year, we've had the ability to provision disks, including partitions and file systems, on your compute node. So this was handled during init. Your node would boot up, and it would discover some configuration for a subsystem called Ignition, which is a project out of the CoreOS project. It would see generated configuration that we had put on the node based on what you said you wanted your node to have, that would tell it, you should have these partitions on this disk, and they should have these file systems. And it would inspect the disk layout, and if it didn't match, it would make it match. We've had that for over a year. And so with this, you can have a local file system that is a local scratch. Let's say you have like a local NVMe, you want to expose that as local scratch. Maybe you want to have state in var because you have some application that wants to persist state between reboots and you want that to be local to the node, you can totally do that. You can put var on a disk and configure it this way and tell it to mount it at var. And then sometimes people want a swap, which might seem odd, but if you otherwise have this big image in memory, you can create a swap partition, and then it can swap the image back out to swap, and that's a way to get it back onto disk without having to worry about actually provisioning it to disk. So those are things you've been able to do for a little while. But a brand new feature that we've added is the ability to actually provision the image to disk during the initial boot. And so the way we implemented this is we moved the ability to provision disks a little bit earlier in the boot process. So we were doing that during init. You can still do that during init. But now you can do it in the Warewulf init, which is before it hands control. Well, actually, it's even before Warewulf init. It's happening in the first stage of the boot. So we build a dracket, a init-ramfs, or a init-rd, and we added a Warewulf plugin to that lets it get configuration from Warewulf and see what it should do. And one of the things that it should do is provision your disk. So since we're in this pre-init state where we can run some code before the image has even been fetched from the server, one of the things we can do is provision a file system on the disk. And now that we have a file system, instead of write the image to a tempfs, you can write it to a root, like to a disk root. And I will demonstrate this now. Bear with me for just a moment while I figure out how to switch my displays over here. There we go. So this here is Warewulf Pro, or it's the web interface for Warewulf Pro. Can we see that okay? I can't see the screen as well as you, but so this is a really simple test system. Of course, I have a cluster with one node in it. This node has 3 profiles. It has a default profile. It has a bond profile, which is a little bit interesting because I was using this environment to test Ethernet bonding. And so I put all that configuration in an overlay, and I can just turn it on or turn it off by adding or removing that overlay. And then I have an OpenHPC profile that tells it to boot into my OpenHPC image, one that closely resembles the one that comes from the Warewulf Pro stack. This here is my virtual, oh wait, no, this is the server. This here is the compute node booted into that environment. And you know what, I'll just SSH over to it here. So things to see is how much memory we're using. We see that we're using upwards of 2 gigabytes of memory here, and I'm not doing anything on this node. This is the kernel and the image that are taking up this memory. And then, no, not this. We can look at what's mounted at root, and we see that root is mounted at /, which is a tempfs. Of course it's mounted at /, it's root. But it's a tempfs, which is what is consuming the majority of this memory here. So what we can do, and we'll just kind of demonstrate the value of this web interface here. All I have to do is go over here and edit this node and see its list of profiles, and I will look for the one that I have pre-made, and we'll look at this profile while it's booting. But I have a disk root profile. It, of course, can be named whatever you want. I'll save it, I'll build my overlays, and then I will tell VMware to reboot it. I guess I could have just said reboot in that terminal session. And while it's coming up, let's look at what that thing is. Do I still have this terminal? We'll just do it here. No, we won't do it here. We'll do it back here again. Oh. Did I reboot the... Oh, no. I see what I did. I rebooted the node while I was SSH'd into it. We will do this. There we go. So this is the disk root profile. One thing I didn't talk about for people that aren't already familiar with Warewulf is everything in Warewulf is as transparent as we can make it. A disk image is just a directory on your file system that has a root FS in it. Like you can just go see the files. Overlays are the same. They're just a directory that have files and templates in them. And they are, they have a root FS directory and everything is relative to that. And the configuration, including the nodes and profiles, are just YAML in a YAML document. So I'm using a command to fetch this, but it's also just Etsy werewolfnodes.conf, and it's just a pile of YAML where all the nodes and profiles are. So everything is really transparent, really easy to see what's going on, really easy to generate yourself or to check into Git and version control, that kind of thing. But let's look at this profile that I'm booting right now. All it does is say, hey, I want my root file system to be on this thing, and we use naming so that we don't have to worry about like what disk it is at that point. We're using the file system or partition label to find it. And then I say I have this disk, and I'm going to wipe it every time because I'm going to be stateless because that's how I like things to be. Sorry, I bumped the microphone for the recording there. But I'm going to wipe it, and it should have this one partition on it called rootfs. And then on that rootfs partition, I'm going to create a file system called an ext4 file system, and I'm going to mount that at root. And so what happens at runtime is we use Ignition to generate this. And if you don't have Ignition, we also support it with sfdisk and makefs and makeswap. So even if you're in an environment that doesn't have that, you can still use more basic tools to implement this. And that's all just in the overlays that we ship with it. Oh, but we can set up this disk with a partition, set up a file system on that partition, and then tell it to write root to it. And we should be booted at this point. Oh, too many windows. What? You know what they say about live demos? I literally did this 3 times over there before I walked over here. Why is it coming up without an image? Oh, this is still dead. Well, for the purposes of your time, I will just show the slide, and then we'll continue trying to get it to work for real. I've literally never had it not work until this moment. But let's come back to this. I want displays. Cool, that worked. So, oh yeah, I have an actual slide for this, so I will show that. So many things going wrong. Oh, it's this up here. Okay, great. Now I have this whole thing I have to do. So yeah, the final thing we were trying to show is that when you're booted into the image, you also see that you're on an ext4 instead of the tempfs, and then your memory is much lower. It still says, 500 meg, this is what the kernel has reserved for things. We can't go smaller than what the kernel will take. But as your image gets larger, this becomes a much bigger difference, of course, because if you have a 12 gigabyte image, now it's not just in memory all the time. That may or may not matter to you. You may want to have it in memory. There are reasons to want to do that, but this is a benefit. And demo. So, the next steps from here for an actual, what we think people mean by stateful provisioning. So when you do this, every time you turn the node on and boot, it's getting the image over the network and writing it to disk every time. So we are going to add the ability to configure a bootloader on the node so that it can boot even without the Warewulf server, without having to reprovision the image every time, if that is a thing that you want. Right now, the current plan is to do that by configuring your EFI partition with Warewulf and having it insert the necessary boot parameter into that partition. An alternative would be to have a grub thing that we configure. So when we actually get into that, we'll make that decision. But the current thought process is to do it with EFI. And then the current 2-stage boot process and this provisioning to disk, we've kind of been covering ourselves a bit in the community by just putting an asterisk next to it and saying it's a preview. And that's because we're trying it out and getting it in people's hands, and it might change. Not that it's going to go away. Lots of people are using it in production, but it's not stable in the sense that the interface for it might change. And so we need to get out of that. We need to actually stabilize this thing and have it be a non-preview feature so that people can use it with confidence. And so those are our early 2026 goals for this product and project. A couple things before we end. One is that if you're using Warewulf or you're interested, there is a Warewulf community that you can find more information about at warewulf.org/help. Will tell you where the Slack community is, and that's where most of the communication happens. And then we have a user group meeting on the second Wednesday of each month, and if you would like the calendar invite for that, the best way is to join the Slack and ask for it. And Rose, wherever she is, that Rose back there, will send you the calendar invite for it, and we'd love to get you on there. We invite people from the community to give presentations about what they're doing with Warewulf, and share tips and tricks and best practices, and we give updates about just like this, what new features are coming up, what new features have landed recently. And then if you would like more information about Warewulf Pro, well, you're in the right place. We are CIQ, and we build and support Warewulf Pro. But you can also learn more about it at ciq.com/Warewulf, and by coming up here and talking to me. All right, thank you very much for your time and for your attention.